This video is about EGA and trying to recreate the EGA experience without actually owning any EGA equipment. EGA is an interesting one. It was wedged in there between CGA and VGA, but it was really the first ubiquitous 16-color standard for the IBM PCs and compatibles. And how it actually looked when running on proper EGA equipment is one of those things that sort of got lost a little bit to time. And what we're going to do today is actually try to recreate that experience without owning any of the original EGA equipment. Okay, so we'll dive into some specs first here. So a true or actual 320 by 200 EGA game, when running on an EGA card and a compatible monitor, is displayed at 240p at 60 hertz. And so what that means is that we actually have 60 frames a second getting displayed there. And there's about 240 active horizontal lines. But because it's 320 by 200, we actually lose 40, or we're not displaying 40 of those lines. And that results in approximately 20 black horizontal bars on the top and the bottom of the picture. Interestingly enough, when VGA came out, it provided, from at least the software's perspective, a compatible interface to play EGA so that the software didn't have to be updated to work with VGA. It talked to the VGA card as if it were EGA. Now, on the actual end user side, we got a much different experience as a byproduct. And so when those 320 by 200 EGA games were running on a VGA card, that VGA card actually sent a 450p at 70 hertz signal to the VGA monitor. And so while we still got those same black bars on the top and bottom, maybe a few more just as a byproduct of the resolution being sent, what it did is it actually ran the game at a different refresh rate or different frame rate. It also, as a byproduct, because it was sending a 450p signal instead of a 240p signal, it actually had to go and double all those 200 lines in the EGA game in order to fill that space. And so instead of it actually displaying the standard resolution of 200 lines, it actually displayed 400 lines, where all those 400 were just made up of doubles of the 200. And when we kind of go back and look at how those original designers intended the games to look, what you got when you played them on a VGA card was, I would argue, a significantly different experience than what the designers themselves had cooked up when they were originally designing those games on an EGA monitor. So we're going to do a quick case study here using Space Quest 3. Of course, I own the box copy of it because you gotta. One of the best EGA games, in my opinion, that's ever been created. We're going to do a deep dive here just on the actual captures of what it looks like to see this game on EGA and VGA monitors and what that really brings to the table. So if we kind of look at this cool opening screen here, where we've got the Pirates of Pestilon being displayed. If we deep dive on that first P in Pirates, what we'll actually see here is I've got different captures that I took with the camera of how it appears on real EGA, and then how it would appear on a VGA CRT monitor, and then subsequently on the most horrid experience of them all, which is LCD. So on the far left there, as we can see, running at 15 kilohertz, 240p, we've got nice black lines between each horizontal line there. And that's how, essentially on a monitor that's got the potential to display 480 lines, how you actually only display 240 of them is you leave a gap between each of them. And so it's quite a large gap, and it gives you some natural anti-aliasing. As well, we can see, just due to the dot pitch of the monitor, that's the spacing between the holes that the electron beams actually shoot through, we can see some nice big spacing between them. And so that kind of also adds a little bit of nuance to the feel. As we move over to VGA, and how that EGA game looks there. So that middle one, we're kind of seeing a little bit more what we'll call stair stepping or pixelation. And this is, again, a byproduct of simply the VGA card doubling every line. So instead of having this more natural separation where those different lines can kind of blur a little bit more, we're actually seeing now data being repeated on the subsequent line. And that's actually forcing a little bit more of a chunky pixelated look. In addition, depending on sort of how high resolution your VGA monitor is, that dot pitch, so that spacing between the dots, can be very fine. And so we're not really seeing any horizontal separation as well. So we're losing a little bit of nuance on that front too. Lastly, on the far right there, that EGA on LCD is just an abomination to all things. We see no scan lines at all. So everything is coming out extremely chunky and blocky looking. Of course, if you just want to play a game as a last resort, that's fine. But when we're talking about that EGA experience there, you can just see that it absolutely is not able to recreate it to any extent at all. So we're just going to ignore that one for this further deep dive here. Again, look very, very closely at that stair-stepping pattern. What I've done here is I've actually drawn in just sort of a geometric blob, and I've kind of traced that diagonal line coming down the P there to sort of show that just when you display it at 240p, you're getting a bit of natural anti-aliasing as a byproduct. Whereas when you look at that same white geometric blob there, on the VGA side, when I run it and place it in the exact same position, you're seeing a lot more stair stepping or aliasing as a byproduct of that line doubling that's occurring. So again, it's making a game look more chunky and blocky than it should. Now, the challenge we've got is that EGA equipment is rare and expensive. There's also another issue of EGA cards actually having challenges running on faster computers. And you can go Google on Vogons or other places and kind of find people who've tried to do different things with various degrees of success. But the fact of the matter is, it's just becoming harder and harder to get a properly running EGA rig these days. But where we're fortunate is that the actual resolution and frame rate of EGA can be forced out of a VGA card. But the problem is that those VGA monitors actually aren't built to receive that signal. So the VGA cards can produce it, but the VGA monitors can't actually display it. And so what you have to do is you have to find another 15 kilohertz capable analog CRT to display that signal on after you've got it out of the VGA card. And so here's some options that I've kind of come up with. You could get something like an old Commodore RGB monitor, which takes analog RGB at 15 kilohertz. The challenge here is these are starting to become expensive and rare themselves. You could go down the route of using an arcade monitor. There's some interesting nuances you have to do there to make that work. And again, these things are starting to become rare and expensive in and of themselves too. The last and probably still easiest option is actually to get your hands on an NTSC TV because they happily take that signal as well. I don't believe a PAL TV is going to work or a CCAM TV is going to work because of the expectation to be able to display that 60 hertz signal. Now, you might find some models that actually can take 60 hertz and maybe it will work, but using an NTSC TV is guaranteed to work because the EGA resolution and refresh rate is exactly that of what an NTSC TV will take. So when we do this, when we actually run EGA games using a modified VGA signal on an old 15 kilohertz capable CRT, we get a perfect EGA experience without actually having to own any of the EGA hardware. And the cool side effect is that when you run VGA games on such a rig, you get this console-like VGA experience, which is totally different from how we're used to playing VGA games. But can be kind of cool in its own right. So in this example here, I'm actually playing Doom on 240p. So it's Doom running on a VGA card, outputting that 240p signal to an analog CRT instead of a VGA monitor. Looks very cool. Now, the challenge we've got is none of these old TVs or monitors are plug compatible with the VGA adapter itself. And a lot of them aren't even compatible with RGB signals. And so you've got to buy some sort of middleman transcoder to make it all work. Why it's important to get a transcoder and not something that does any frame buffering or digital manipulation is that those things start to add lag. So you need something that works purely in the analog domain where it's literally converting those VGA RGB signals to an analog format that your display device can handle in real time. You do not want to have any lag. So there's a device out there. You can find them on eBay. They're a little bit more expensive. They come out of New Zealand, but they can do VGA to S video transcoding in real time. So they're pretty cool if all you've got is S video on your monitor. In even better and actually very cheap option now, you can find these all over AliExpress, are VGA to component analog transcoders. Again, no lag. Super cheap. They've worked super well, at least the ones I found. So you can Google around and try to get your hands on one of these. But they expect you to have a component monitor or component TV. If you don't have a component capable television, obviously this is a no-go. The S-Video one also has a composite output. It's going to look really bad, but I guess if your TV only had composite input, that's a way of going, but you're going to get a ton of noise and dot crawl and the like. So it's going to start to get into an area of diminishing returns if you don't have a TV that at least has S-Video. Your other option is, and this is the very complex one, one I probably actually wouldn't recommend for the average user, is you can actually get into your TV and you can hack the Jungle IC RGB lines. And so what this is doing is actually taking the VGA RGB output and hardwiring it straight into the television. And so you're bypassing whatever external adapters the TV has and just forcing a VGA signal right into it. You also need to create a sync signal combiner impedance matching circuit so that you're taking the VGA's horizontal and vertical TTL syncs, you're combining them together and you're getting them down to a level that's appropriate for working with an old NTSC television. So again, this is a much more complicated route to run, but one where ultimately if your TV didn't have S-Video or component, you could actually modify it to accept VGA, but very complex. 8-Bit Guy's got a great video on how he sort of did this. If you're lucky enough to own an actual 15 kilohertz RGB monitor with the linear RGB input, it's literally just a matter of wiring your VGA output into the appropriate pins on the linear RGB input, and it just works. Lastly, and another complex option is you could do it on a standard resolution arcade monitor. You're also going to have to buy some additional hardware to pull this one off because you actually need an RGB amplifier that's going to take that VGA signal and it's going to amplify the RGB lines to be compatible with those monitors. So again, a rare thing to own a monitor and then some additional hardware you're actually going to need to make it all work. But it is possible as well. Now, the interesting part is how do we actually get that 15 kilohertz signal out of a VGA card? And the sort of easy route can be going with Windows, where if you buy a compatible AMD card, you download CRT EMU driver, you create a custom Modeline, you do a little Dosbox config, and it sort of all just works. So Calamity, the author of Groovy MAME, actually makes this amazing driver for AMD cards, which allows them to run at 15 kilohertz. And so you actually can have Windows running in 15 kilohertz, which also looks amazing for playing, digital copies of your old VHS and Laserdisc movies. So you can get this driver for free. You have to buy a compatible card. And then if you go into your DOSBox config and you make some modifications, really you're just trying to force DOSBox to use 320 by 200 as its native resolution, and then change your machine type to EGA to get it to run at 60 frames a second instead of 70. That's really all that's needed on the DOSBox side. And then for CRT EMU driver, I created a custom 320 by 200 Modeline. And so when DOSBox kicks into 320 by 200, this Modeline is actually turned on by the card and everything works perfectly. Here's a quick video of sort of what that looks like. The downside of forcing DOSBox to 320 by 200 is that the text modes that run at actually a different resolution look really, really ugly. So until you actually launch the game, which looks gorgeous, the text modes actually look distorted. So it can be a little bit off-putting. Okay, so that's the way to do it with Windows. We can do a lot better. We gotta run this on bare metal DOS. There's different programs you can download that will actually force your VGA card to run in this 15 kilohertz mode. I had the absolute best luck, especially on EGA games running with VGA TV. And what's kind of neat about this application is that the original authors actually still released the source code. Now, their site is offline and there's a mirror of it. So, what I've done is I actually downloaded the source code, the original license, and the last compiled version of VGA TV. I put it on this GitHub site here. And so it's accessible, you can get it. And if someone really wanted to, they could fork it and actually try to enhance VGA TV to make it maybe even better than it is. I wanted to call it an honorable mention. This just doesn't show up on enough sites these days, is the Advanced Cab utility by the author of Advanced MAME. And what this is it's an amazing tool that you can go and build custom mode lines and all the like for VGA gaming on classic NTSC or PAL televisions. Just such a well-written tool with so many different options and I would say infinite configurability. The challenge I had was I could just never get it to work with EGA. So it worked great on VGA, a lot of video cards and the like supported, but it just didn't work for EGA. And so I couldn't use it on this project. Going forth again, VGA TV was the answer and so easy to use. These are the command line options that were issued in order to get the monitor to start running in 15 kilohertz mode. My recommendation is because you have to sort of flip between your VGA monitor and your NTSC or 15 kilohertz compatible monitor, is to get a switch. Ideally, you put this command in your autoexec bat. And then when you reboot, all of a sudden, when this runs, your VGA monitor will go offline because it can't sync anymore. Then you'd hit your switch and you'd actually then cut over to your 15 kilohertz monitor and you'd resume the rest of your session. So that's kind of the route that I take. You can also just, plug the different cables into the different things as you're doing stuff. Or once you've modified your autoexec bat, you can actually just leave your 15 kilohertz monitor turned off until you're reasonably confident that DOS is booted, and then you can turn it back on. So ultimately, video card compatibility of VGA TV seems to be actually reasonably broad. There's a lot of cards that I've tried that aren't on their official list because they do have generic driver included. Now, the challenge is that as soon as I cut into EGA mode, I was getting massive amounts of underscan on several of the cards. And I'm not sure if that's a byproduct of those cards actually not being fully compatible, where the author maybe didn't account for some of those nuances, or whether it's just the fact that those cards operate different at a firmware level that's maybe below what can actually be configured. And they're just not accustomed to running EGA at the appropriate scan width that one would need in order to actually fill the full screen. So it's really hard to say, but what I've come up with here is a few different videos of what those experiences were. So the first card that I tried out was just a classic NVIDIA TNT2. Again, looks great on VGA, but when I kick it into EGA mode, you can see that underscan. It really just squishes everything in the middle there. And so just not a great experience. Moving on, I tried an ATI Rage Excel PCI card. Again, looks wonderful in VGA, but had the same underscan challenge when I tried an EGA game. And then the last one, I dug out an old Trident 8900C, and voila, it works perfect. So it's actually able to fill the full screen, so it's not underscanning in EGA mode, and works just absolutely perfect. So because, again, I saw Trident on the list there of supported manufacturers, I'm not sure if that's inherently because they've done some stuff there with the Trident code to make it work. And it may be possible that if I had an S3 card or an Oak card or a Realtek card, something would work better there too. It's really difficult to say. But for now, running it on that Trident card was the only way I could actually get it to display the proper scan width. So just to recap, we've forced VGA cards to output 15 kilohertz signals, which is the same rate that EGA ran at. And then we've got various adapters or mechanisms to utilize the signal coming out of those cards on things like NTSC TVs or the like. And when we do that and combine them and then play EGA games, we're actually able to recreate the pixel accurate EGA experience, but without having to own any of the EGA hardware. I hope you enjoyed this December video. Happy December, everyone.